Hello everyone, welcome back to my YouTube channel Physics Unification.
In previous chapter, we described the motion of a particle in a plane. Today, we are going to learn a new chapter from the first PUC, that is laws of motion. And that chapter itself, it gives the answer for our some common experience. For example, to move a football which is at rest, someone must kick it. A breeze which causes the branches of a tree to swing. A strong wind can even move heavy object. Clearly, some external agency is needed to provide force to move a body which is from rest position. In short, what we can tell, a force is required to put a stationary body in motion or stop a moving body, and some external agency is needed to provide this force. The external agency may or may not be in contact with the body. First of all, we can learn the Aristotle fallacy, means Aristotle's statement regarding laws of motion. An external force is required to keep a body which is in motion. For example, what we can take, an arrow which is shot from a bow keeps flying since the air behind the arrow which keeps pushing it. Next, what we can say, the laws of inertia, which is explained by the Galileo. If the net external force is zero, means whatever that net external force we can consider that is equal to zero, means a body which is at rest continues to remain at rest. A body rest allೇ continue ಆಗ್ತಾ ಹೋಗ್ತದೆ, and a body in motion continues to move with a uniform velocity. ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿ ಒಳಗೆ ಆ ಬಾಡಿ ಮೂವ್ ಆಗ್ತಿದ್ರೆ ಅದೇ ವೆಲಾಸಿಟಿ ಒಳಗೆ ಅದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇರ್ತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿಚ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್, let's see. When the bus stops suddenly, people fall forward. A second example, falling down of dust particles while dusting a cloth. And third example, we can say that one is law of inertia example. Due to inertia, artificial satellite keep moving in a circular motion. And itself it gives the law of inertia concept. Next, what we can say, Newton's first law of motion. That one is law of inertia statement. Itself it tells the law of inertia statement. Every body continues to be in state of rest. Body state of rest position ಅಲ್ಲಿ ಇರ್ಬೋದು, or of uniform motion ಒಳಗೂ ಇರ್ಬೋದು, in a straight line, unless compelled by some external force to act otherwise. ಅದ್ರ ಮೇಲೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗೋವರೆಗೂ ಅದು ರೆಸ್ಟ್ ಪೊಸಿಷನಲ್ಲಿದ್ದರೆ ರೆಸ್ಟ್ ಪೊಸಿಷನಲ್ಲೇ ಇರುತ್ತೆ, ಆರ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನಲ್ಲಿ ಇದ್ದರೆ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನಲ್ಲೇ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇರುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ನ್ಯೂಟನ್ಸ್ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಇಸ್, ಅ ಬಾಲ್ ರೋಲಿಂಗ್ ಡೌನ್ ಅ ಹಿಲ್ will continue to roll unless another force stops it. Next concept, it is Newton's second law of motion. Before going to that one, we should know the concept of momentum. Momentum means the capacity of the body to give a motion to another body. That gives P is equals to M into V. How we can write the SI unit of momentum? That is kg meter per second. Mass is kg, velocity is meter per second or Newton second. Dimensional formula for momentum is m l t minus 1. Next concept, it is Newton's second law of motion, which tells the rate of change of momentum, that is dp by dt, of a body is directly proportional to the applied force and takes place in the direction in which the force acts. That is, dp by dt is directly proportional to the force. That one is applied force and which takes place in the direction in which the force which is acting. So let us derive the formula. That one is F is equals to ma formula based on Newton's second law of motion. And this derivation is important for 3 marks. If under the action of force F for a time interval delta t, what we can take? Velocity as v, which changes to v plus delta p. And we know P is equals to m into V, means momentum is equals to m into V, and which is changes by delta P is equals to m into, in place of V, what we have to write? Delta V. According to second law of Newton, which gives force, applied force is directly proportional to the change of momentum, delta P by delta T. So, F is equals to, just by removing proportionality sign, what we will get? K, proportionality constant K into delta P by delta T. Taking limit as delta T tends to 0, which gives the term delta P by delta T changes to dP by dt, means derivative of momentum, which gives. Then force can be written as F is equals to K into dP by dt, which is equals to, in place of K, as it is, so we should write K value. In place of dP by dt, what we have to apply? Value of P, that one is m into V. K into d by dt of m into V. Here m is constant, that one is the mass. Just take outside K into m and dV by dt. And we know rate of change of velocity is acceleration. Therefore, which gives F is equals to K into m into A. Right? F is equals to 1 or mass is equals to 1 and A is equals to 1, then value of K, which is equals to the 1. Therefore, F is equals to dP by dt, which gives m into A. This one is the derivation for F is equals to m into A. Next concept, it is impulse. How we can define impulse? A force which acts in a time, means force into time duration, which gives the impulse. Example, when a ball hits a wall and which bounces back. Back side alli ನಾವು ಬಾಲ್ ಅನ್ನು ಹಿಟ್ ಮಾಡಿದ್ರೆ ಅದು ರಿಟರ್ನ್ ಆಗಿ ಮೂಮೆಂಟ್ ಆಗ್ತದೆ ವಿದಿನ್ ಅ ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್ ಅಲ್ಲಿ, ದಟ್ ವಿಚ್ ಗಿವ್ಸ್ ಇಂಪಲ್ಸ್. ಅಂಡ್ ಇನ್ ದ ಸಿಮಿಲರ್ ವೇ ಇಂಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಮೀನ್ಸ್ ಲಾರ್ಜ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಫಾರ್ ಅ ಶಾರ್ಟ್ ಟೈಮ್ ಅಲ್ಲಿ ಲಾರ್ಜ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಅ ಫೈನೈಟ್ ಚೇಂಜ್ ಇನ್ ಮೊಮೆಂಟಮ್. Example, hammering a nail into a wall or hitting a ball by a bat. SI unit of impulse is Newton second or kg meter per second. Dimensional formula is m at t minus 1. Next, we can move towards Newton's third law of motion, and this one is already we know. That one is, for every action there is always equal and opposite reaction. We can see some more examples based on Newton's third law of motion. Example 1. While walking, a person presses the ground backward. ವಾಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಪರ್ಸನ್ ಗ್ರೌಂಡನ್ನು ಬ್ಯಾಕ್ವರ್ಡ್ ಅಲ್ಲಿ ಪಾಸ್ ಮಾಡ್ತಾನೆ, ಮೀನ್ಸ್ ಪ್ರೆಸ್ ಮಾಡ್ತಾನೆ ಬೈ ಹೀಸ್ ಫೀಟ್. ದ ಗ್ರೌಂಡ್ ಪುಷಸ್ ದಿ ಪರ್ಸನ್ ಫಾರ್ವರ್ಡ್ ವಿತ್ ಈಕ್ವಲ್ ಫೋರ್ಸ್. ಗ್ರೌಂಡ್ ಆ ಪರ್ಸನ್ನ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪುಷ್ ಮಾಡ್ತದೆ. ದಟ್ ಒನ್ ಇಸ್ ದಿ ನ್ಯೂಟನ್ಸ್ ಥರ್ಡ್ ಲಾ ಆಫ್ ಮೋಷನ್. ಫಾರ್ every action there is equal and opposite reaction. Let us see the second example. That one is, when a tennis ball is thrown against a wall, what happens? A ball bounces back due to the reaction of the wall. There is also action and reaction. And in third example, we can see a swimmer pushes water backwards. Backward directionally swimmer water na push ಮಾಡ್ತಾನೆ, and in turn water pushes him ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅವನು ಮೂಮೆಂಟ್ ಆಗ್ತಾನೆ. These are the examples for Newton's third law of motion. Next concept, it is conservation of linear momentum. The total momentum of an isolated system of interacting particle is conserved. Total momentum ಏನಾಗಿರ್ತದೆ? That one is always conserved. And this one is also important for 3 marks. 3 marks is important in the derivation. Let us take the proof. Consider two body A and B. ಎರಡು ಬಾಡಿನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ವಿತ್ ಇನಿಷಿಯಲ್ ಮೊಮೆಂಟ PA and PB. And final momenta be PA dash and PB dash. From Newton's second law, how we have to write? That one is F is directly proportional to dP by dt. And here two momentas are there, means final and initial momenta. Let us take FAB can be written as PA dash minus PA, and FBA into delta T is equals to PB dash minus PB. By third law, means Newton's third law, For every action, there is opposite reaction. FAB is equals to minus of FBA. FAB, how we have to write? PA dash minus PA. That one is equal to minus of FBA is PB dash minus PB. Just by simplification, what we will get? PA dash plus. Here it is minus. When it is comes to left hand side, it becomes plus. Plus PB dash is equals to PA. Means in left hand side it is minus. When it is comes to right hand side, it becomes plus. PA plus PB. Means here which tells final momentum which is equals to initial momentum. Means that one is conserved. Total momentum means total final momentum of the isolated system is equal to the total initial momentum. This one is the proof for the conservation of linear momentum. Next concept, we can see the concept of friction. Friction means force which opposes the relative motion between two surfaces in contact. ಎರಡು ಸರ್ಫೇಸನ್ನು ನಾವು ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆಗಿರುವಂಥ ಅಪೋಸಿಂಗ್ ಫೋರ್ಸನ್ನು ನಾವು ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. There are three types of frictions are there. One it is static friction, another one it is kinetic friction, another one it is rolling friction. Let us see the example and definition of static friction. Static friction means it is the force of friction which exactly balances the applied external force when the body is in equilibrium. Force of friction ಅಪ್ಲೈಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸಿಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಆದಾಗ ಅದನ್ನು ನಾವು ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಕ್ಸಾಂಪಲಲ್ಲಿ ನೋಡ್ಬೋದು, ಅ ಬುಕ್ ಮಾರ್ಕ್ ಇನ್ ಅ ಬುಕ್, ಅ ಕಾರ್ ಪಾರ್ಕ್ಡ್ ಆನ್ ಅ ಹಿಲ್. That one is the example for static friction. Next one concept it is kinetic friction. That one is also called it as sliding friction. A frictional force that opposes relative motion between surfaces in contact. ಎರಡು ಸರ್ಫೇಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆದಾಗ ಅಪೋಸ್ ಮಾಡುವಂಥ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸನ್ನು ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಕ್ಸಾಂಪಲ್, ವಿ ಯೂಸ್ ಅ ನ್ಯಾಪ್ಕಿನ್ ಟು ಡ್ರೈ ಅವರ್ ಹ್ಯಾಂಡ್ಸ್. ನ್ಯಾಪ್ಕಿನ್ನ ಯೂಸ್ ಮಾಡಿ ನಾವು ಹ್ಯಾಂಡ್ಸನ್ನು ಡ್ರೈ ಔಟ್ ಮಾಡ್ತೀವಿ. ಮೀನ್ಸ್ ದಟ್ ಒನ್ ಇಸ್ ದ ಫ್ರಿಕ್ಷನ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ ಹ್ಯಾಂಡ್ ಮತ್ತು ನ್ಯಾಪ್ಕಿನ್ ಮಿಡಲ್. ದಟ್ ಒನ್ ಇಸ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಎಕ್ಸಾಂಪಲ್, ವೆನ್ ಯು ರೈಡ್ ಅ ಬೈಸಿಕಲ್ ಆನ್ ಅ ರೋಡ್ ಮೇಲೆ ಬೈಸಿಕಲ್ ವೀಲ್ ಮತ್ತು ರೋಡಿನ ಸರ್ಫೇಸ್ ಮೇಲೆ ಕ್ರಿಯೇಟ್ ಆಗಿರುವಂಥ ಫ್ರಿಕ್ಷನ್ನ ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. Next one concept it is rolling friction. That one is kinetic friction which comes into play when a body rolls over the surface of another. Kinetic friction ಯಾವಾಗ ಅಪ್ಲೈ ಆಗ್ತದೆ? ಆ ಬಾಡಿ ಆ ಸರ್ಫೇಸ್ ಮೇಲೆ ರೋಲ್ ಆದಾಗ. ದಟ್ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಇಸ್ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್. ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡ್ಬೋದು ನಾವು, ಆ ಬಾಲ್ ಬಿಯರಿಂಗ್ಸ್ ಪ್ಲೇಸ್ಡ್ ಬಿಟ್ವೀನ್ ಮೂವಿಂಗ್ ಪಾರ್ಟ್ಸ್ ಆಫ್ ಅ ಮಷೀನ್. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಟ್ ಈಸ್ ಲಾ ಆಫ್ ಸ್ಟ್ಯಾಟಿಕ್ ಆ್ಯಂಡ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಇದಕ್ಕೆ ಫಾರ್ಮುಲಾಸ್ ಹೇಗೆ ಬರೀತೀವಿ ನಾವು? ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನಿಗೆ ಎಫ್ ಇಸ್ ವೆರಿ ಮಚ್ ಲೆಸ್ ದೆನ್ ನ್ಯೂ ಎಸ್ ಇಂಟು ಎನ್ ಆ್ಯಂಡ್ ನ್ಯೂ ಎಸ್ ಇಸ್ coefficient of static friction. Kinetic friction Fk is equals to nu k into n and nu k is equals to coefficient of kinetic friction. Next one concept it is advantage of friction, and this one is very important for 2 marks. Advantage, disadvantage and method of reducing friction ಅವೆಲ್ಲ 2 ಮಾರ್ಕ್ಸಿಗೆ ಫೈನಲ್ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳುವಂಥದ್ದು. ಅಡ್ವಾಂಟೇಜ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ನ ನೋಡುವ. ವಿತೌಟ್ ಫ್ರಿಕ್ಷನ್ ಒನ್ ಕೆನಾಟ್ ಹೋಲ್ಡ್ ಎನಿಥಿಂಗ್ ಇನ್ ಒನ್ಸ್ ಹ್ಯಾಂಡ್. ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಅಂದರೆ ನಾವು ಈ ಪೆನ್ನನ್ನು ಕೂಡ ಕೈಯಲ್ಲಿ ಹಿಡ್ಕೊಳಿಕ್ಕಾಗೋದಿಲ್ಲ. ವಿತೌಟ್ ಫ್ರಿಕ್ಷನ್ ವಿ ಕೆನ್ ನಾಟ್ ವಾಕ್. ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲದೆ ನಾವು ಮೂವ್ ಮಾಡಲಿಕ್ಕೂ ಆಗೋದಿಲ್ಲ. ಆ್ಯಂಡ್ ವಿತೌಟ್ ಫ್ರಿಕ್ಷನ್ ವೆಹಿಕಲ್ ಕಾಂಟ್ ಮೂವ್ ಆನ್ ದ ರೋಡ್ ಆ್ಯಂಡ್ ಕೆನಾಟ್ ಬಿ ಸ್ಟಾಪ್ಡ್ ಬೈ ದಿ ಅಪ್ಲೈಯಿಂಗ್ ಬ್ರೇಕ್ಸ್. ಆ್ಯಂಡ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ದಟ್ ಒನ್ ಇಸ್ friction which causes the power dissipation in the form of heat, sound, etc. Friction usually heat, sound produce ಮಾಡುತ್ತೆ and which causes the power dissipation. And efficiency of a machine is reduced. Reduce ಹೇಗಾಗುತ್ತೆ? and extra energy is required to overcome the friction. ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕಾಗ್ತದೆ ಫ್ರಿಕ್ಷನ್ನ ಓವರ್ಕಮ್ ಮಾಡಲಿಕ್ಕೆ. ಆವಾಗ efficiency of that machine will be reduced. And friction which causes the wear and tear of the machine and reduces their lifetime. ಬೇಗ ಆ ಮಷಿನ್ ಹಾಳಾಗುವಂಥ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಫ್ರಿಕ್ಷನಿಂದ. ಆ್ಯಂಡ್ ವಿಚ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಹೀಟ್ ವಿಚ್ ಕ್ಯಾನ್ ಬಿ ಹಾರ್ಮ್ಫುಲ್ ಟು ದಿ ಮಷಿನರಿ ಪಾರ್ಟ್. ಆ ಹೀಟ್ ಮಷಿನರಿ ಪಾರ್ಟನ್ನು ಡ್ಯಾಮೇಜ್ ಮಾಡ್ಬೋದು. These are the disadvantages of friction. Next one, it is methods of reducing friction, and this one is also important for 2 marks. Friction can be reduced. Friction ನಾವು ಹೇಗೆ reduce ಮಾಡ್ಬೋದು? By lubrication with oil, grease or powder, by using ball bearings, by polishing and making the surface smoother, by proper selection of materials which offer low friction. This one is very important for 2 marks.
Next concept, it is circular motion. First of all, we have to know the definition of centripetal force. The force directed towards the center along the radius. Radius in the force center ಗೆ act ಆಗ್ತಿರ್ತದೆ during circular motion. That one is Fc is equals to mv square by r. Example for centripetal force is, for a stone rotated in a circular by a string, the centripetal force is provided by the tension in the string. And second example for this one is, the centripetal force for motion of a planet around the sun is the gravitational force on the planet.
Based on the centripetal acceleration, we can see the example of motion of a car on a level road and motion of a car on a banked road. Let us consider a car which having the mass m, radius r, means a circular motion which having the radius r and moving with uniform speed v. 3 forces acts on that car. Let us say first force, it is the weight of the car. That means W is equals to m into g, which usually acts vertically downwards. This one is mg. And normal reaction which acts usually vertically upwards. Upward direction alli normal force act ಆಗ್ತಿರ್ತದೆ. And third one, it is frictional force. As there is no acceleration in the vertical direction alli ಯಾವುದೇ acceleration ಇಲ್ಲಾಗಿರೋದ ಕಾರಣ, what we can write, n minus mg which is equals to 0. And we know static friction is equals to, which very much less than nu s into n, and which is equals to the value of centripetal force. That one is mv square by r, and which is equals to mv square is very much less than nu s n into r. Then mv square is very much less than nu s r. In place of n, what we can write? N is equals to m into g. Therefore, mv square is very much less than nu s r into mg. Then v square is equals to mm gets cancelled, and which gives v square is very much less than nu s into r g. Therefore, for maximum speed of that car, means v max, which gives the nu s into g into r. Nu s is coefficient of static friction. Let us see the motion of a car on a banked road. Just consider that car which moves on the banked road. And here also 3 forces acts on that car. One, it is weight of that car, usually which vertically acts downwards. Downward directionally a weight of the car act ಆಗ್ತಿರ್ತದೆ. And second, normal reaction, and which acts vertically upward directionally normal reaction act ಆಗ್ತಿರ್ತದೆ, and which result into 2 components. One, it is n cos theta, and another one, it is n sin theta. Third one, it is frictional force, and which acts along the banked road, and that one also result into 2 components, f sin theta and f cos theta. Since there is no acceleration along the vertical direction, the net force along vertical direction must be equal to 0. That one is n cos theta is equals to mg plus f sin theta. That one is equation 1. The centripetal force is provided by the horizontal component of normal reaction n and frictional force f. Centripetal force normal reaction ಮತ್ತೆ frictional force ಇಂದ ಪ್ರೊವೈಡ್ ಆಗ್ತಿರ್ತದೆ. ಅವಾಗ ಏನಂತ ಬರಿಬೋದು ನಾವು? ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ as n sin theta plus f cos theta, which is equals to mv square by r. That one is the centripetal force. That one is the equation 2. Now frictional force f, static friction, can be written as f is equals to that one is very much less than nu s into n. And equation 1 which is changes to n cos theta which is equals to mg plus in place of f what we can write nu s into n sin theta. That one is the equation 3. And equation 2 changes to n sin theta plus in place of f what we have to write nu s into n cos theta is equals to mv square by r. This one is the equation 4. Now equation 3 which changes to, just by rearranging the term, what we will get n into, here in the both the terms n is common, so just take outside n, then we will get n into cos theta minus nu s into sin theta, because nu s n sin theta which is in right hand side, when it comes to left hand side it becomes negative, which is equals to m into g. Therefore n is equals to mg by cos theta minus nu s into sin theta. Then equation 4 which changes to, equation 4 is this one, n into sin theta plus nu s cos theta, because here n and n common, just take outside, which is equals to Vm V square max, means V max square divided by R. Just substitute the value of n equal to mg by cos theta minus nu s into sin theta. Then what we will get? Mg by cos theta minus nu s into sin theta plus nu s into cos theta, which is equals to mv square by r. Here mm gets cancelled, and finally what we will get? V square max is equals to gr into sin theta plus nu s cos theta divided by cos theta minus nu s into sin theta. That is, just by dividing cos theta on numerator and denominator, what we will get? V max square is equals to g into r sin theta, cos theta ಹೊರಗಡೆ ತೆಗಿತೀನಿ, divide ಆಗ್ತದೆ cos theta plus nu s into cos theta by cos theta, all divided by cos theta by cos theta minus nu s into sin theta by cos theta. V max square is equals to g into r, then sin theta by cos theta can be written as tan theta plus nu s. Cos theta gets cancelled, and which gives the value of 1 divided by 1 minus nu s into tan theta. Then V max is equals to square root of g into r nu s plus tan theta divided by 1 minus nu s into tan theta. And that velocity at which there is no wear and tear in tires is called it as optimum velocity. And here nu s is equals to 0 means directly what we will get? V max is equals to square root of gr into tan theta.
Which completes the chapter Laws of Motion. For more videos, stay tuned, like, share and subscribe my YouTube channel Physics Unification. Thank you.